Good morning everyone. Today I am going to describe the technologies which was developed by Mr. Bharat, Ms. Neelam and myself Priyamjit under the guidance of Professor Senthil Murugan, Chemical Engineering Department, IIT Guwahati. Antibiotic is a very essential part for human in day-to-day life. However, the recovery of the same by the conventional method is very costly, which restricts its uses. Therefore, we have come up with an idea with some cost-effective technologies like the standalone forward osmosis process or the integrated forward osmosis and membrane distillation processes, where we can recover the same antibiotic in a very cost-effective manner. Today, I'll demonstrate the work used for recovery of antibiotic rifaximin through forward osmosis process. Firstly, the pharmaceutical effluent from the pharmaceutical effluent. The effluent was treated with the hollow fiber PP membrane 3 times to reduce the turbidity, and after that it was reduced. It was then fed to the rotary evaporator. This rotary evaporator, basically what it does, it removes the ethanol from the pharmaceutical effluent by the difference in the vapor pressure and also the difference in the temperature. And after the removing of the ethanol and some water, the concentration of the effluent gets increased, and after that the increased concentration is fed to the next FO system. The effluent which was collected from the rotary evaporator, the concentrated effluent, is fed into the forward osmosis process. So here in this forward osmosis process, basically this is the membrane module where we use FO membrane, and then we will be using basically a high molarity salt solution as a draw solution basically, and the feed solution is the effluent, concentrated effluent. And due to the difference in the chemical potential difference, there is the flow of water from feed side to draw side, and due to that the concentration of the effluent gets slightly increased. And after each cycle, FO cycle, we measure the concentration of the effluent cycle, and also the sizes of the effluent gets increases, the amount of the rifaximin sizes get increases, and due to that we centrifuge after each cycle to collect the pellet. Basically that's the crystal rifaximin, and after that, after centrifugation, the supernatant solution is again fed to the second FO cycle, and again the cycle continues, and again we centrifuge, and that's why each about like 6 to 7 cycles we continue, and from that we recover more amount of rifaximin particles. Thank you.
Good morning, myself Bhala Singh. I am working on that project and as a senior research fellow. This is our VMD unit. This is our feed tank which we fed with pharmaceutical effluent. There is a invent heater, and this is also a feed pump. And by the help of feed pump, we will send optimized flow rate to the VMD unit, also DCMD unit. And here we will connect temperature sensors inlet and outlet side, and this is a vacuum line. Other side we will apply vacuum, and converted ethanol water vapors condensed by this heat exchanger, and concentrated effluent we will collect this tank, and by the help of heat exchanger we will remove heat from that effluent, and concentrated effluent we will send to the centrifuge, and by the help of centrifuge we can separate crystals of rifaximin and mother liquor we recirculate to the fat tank. So this is our whole process of VMD. Thank you.
After completion of the standalone forward osmosis and the VMD process, now we'll go for the experimentation of the effluent in FO VMD hybrid system. Now what happens in this, the solvent is passed through the UF system, UF membrane, and then after the permission of the UF, it goes to the rotary evaporator to remove the ethanol, and then the distillate is the concentrated effluent solution, and then it is centrifuged to get the large part rifaximin crystals, and after that the supernatant solution is fed to the forward osmosis system, where it is where in this process the the high molarity draw solution will extract some water from the feed solution, from the feed effluent solution, and due to that the process gets concentrated slightly. And after that, after each FO process, the solution, the effluent solution, is passed to the FO reject tank, where it is cooled down by using a heat pump, and then the solution is centrifuged, and after that the supernatant solution is passed through again used as the second FO cycle, and the pellet solution is taken as a rifoxamine crystals. And after that, in the same FO process, the draw solution which was getting diluted due to the forward osmosis process is fed into the membrane vacuum membrane distillation unit, where in this process, due to the application of the vacuum pressure, the water and the ethanol from the draw solution is separated, and the high concentrated effluent solution is again fed back to the forward osmosis process as a draw solution. And now for the hybrid FO DCMD process, the process is almost the same till the forward osmosis process, and after that the draw solution, the diluted draw solution is fed into the DCMD unit, where in one side the diluted draw solution is circulated in one direction, and in other direction a cooling tank is circulated. And due to the difference in the temperature difference, the vapors from the draw solution it transferred it to the cooling tank, and due to the condensation, the water and the ethanol gets permeated, and again same the concentrated draw solution is again fed back to the forward osmosis process.